So they will do more integration questions direct into examples. The first set of examples will be on definite integrals. Evaluate the following definite integrals. A, the integral from 1 to 2, 3x squared minus 1 dx. So that we understand what it means to be definite, how to use the numbers 1 and 2. So first thing, you integrate. The integral of 3x squared will be 3x to the power 3 over 3 minus the integral of 1 will be x. So this guy, we're not adding a c because we have numbers 1 and 2. So if we simplify inside, we'll get x power 3 minus x running from 1 to 2. And the next thing we do is we take 2 and substitute throughout where there's x. So we have 2 to the power 3 minus 2 minus, we take 1, we have 1 to the power 3 minus 1. And then simplify, 2 to the power 3 is 8, 8 minus 2, and then minus 1 minus 1. This will give us 1 minus 1 is 0, 8 minus 2 is 6. So 6 is the integral from 1 to 2 of 3x squared minus 1. So it's called definite because it has numbers 1 and 2. So here the interest was just on the substitution of 1 and 2 and not the integration, because it's a very, very easy question that no one may ask.
So, sir, where you see a constant number, you need to replace it with an x, or how is it?
When you're integrating,
Okay,
the integral of 2, we are assuming that the power of x is 0 for it to be 2. The power of x is 0. Then to integrate, we add the 1 and divide by what we get. Then add the c. So it will be 2x 0 plus 1 is 1 over 1 plus c. So we get 2x plus c. That's why when there's a constant, we multiply it by x. We're using that reasoning. Is any question? No question. No.
It's my right?
Yeah, it's my C. The integral from 0 to 1 of negative x e to the power negative x dx. So here you can't use power rule, you can't use substitution, you can't use partial fractions, you can only use by parts. Remember, we said that by parts is used if you have this structure, u dv is equal to, if I have this structure to integrate, then I'll integrate it as uv minus the integral of v du. Where in my question, I'll choose a u which I can differentiate, and it will make the work simpler in the new integral. So in this case, we'll let u to be negative x and dv to be e minus x dx. Then we'll differentiate u, we'll get -1 dx. Then we'll integrate dv to get v, so that we get -e negative x. Since the integral of e power negative x is supposed to be e power negative x over -1. But -1, when you're dividing, you just need a negative from there. Then now we arrange, so we have from 0 to 1, negative x e negative x dx is equal to uv negative x by negative e negative x. Negative negative will give us a positive, and then minus the integral of -1 by negative ex. So just have e negative x dx. Then integrate this guy. So at this point, we are saying from 0 to 1, from 0 to 1, because here we are done integrating. So we'll have x e negative x running from 0 to 1 minus, minus the integral of e power negative x is going to be this one. We just integrated there and we got negative e power negative x. So this negative here, by this negative, we'll have a plus here, and then e power negative x, again from 0 to 1. Then we substitute. So you substitute 1 here and 1 here, you get e power -1 minus, you substitute 0, you have 0 e power -0. And then plus, substitute 1 here, you have e -1 minus, substitute 0, you have e0. So e -1 is there, this is 0, plus e -1, e power 0 is 1, so that's -1. You add these two, you get 2 e -1 minus 1. This is the solution.
So, like I'm a bit behind.
Don't worry.
I'm in the jungle like right now.
That's the second question. Maybe by the time we're doing the 8th exam, you will get back. So you need to understand what it means to use by parts. If you have a product under integration, we don't have product rule here. We have by parts and substitution. If the product is in such a way that you are unable to do any substitution, then you do the by parts. You got your question and break it in 2. So we have -x, e -x. You break this function into 2. The dx here. You need to look for a u. You need to make a function look like u dv. So you got your function and pick the u, call something u that you're able to differentiate. Then the other thing, call it dv if you can integrate it. If you can do the integration of dv, it will give you v. If you can do the differentiation of u, it will give you du. Then because you have u dv, when you do the integration and the differentiation of u, you get uv minus the integral of v du. Then you have this one to integrate again. Let me bring you another example. That comes from integration by parts. Let's check where I find questions. So this was this was C. You go to D, the integral of x, sec squared x dx. If you try to let u be sec squared, you have a lot of work to do to differentiate sec squared. If I asked, you can't even say what the derivative of sec squared is. So what you do is, we rearrange it. It must look like this so that we get uv and then vd. So let u be something you can differentiate, say x. Let dv be something you can integrate, say sec squared x dx. This one will integrate to give us v. The integral of sec squared is tan x. The derivative of x is 1 dx. So now we're saying the integral of x, sec squared x dx is equal to yeah, is equal to uv which is x tan x minus the integral of tan x dx. Which is yeah. What's the integral of tan? The integral of tan is sin x over cos x. So if we let u be cos x, then du is going to be negative sin x du dx. So you can solve for dx, we'll get du over negative sin x, and then substitute. So we'll have sin x over u has been said to be cos, and then dx is du over negative sin. So this piece and this piece can cancel. So we remain with du negative du over u. Leave it there. I remind you something again. You know that to differentiate ln u, if this is y and you are differentiating y with respect to u, you differentiate u and then divide it by u itself. You can write this as du over u. So that to integrate it, to integrate du over u, you must get back the question which is ln u. So the integral of this guy is going to be ln u, the negative is outside. But remember that u will get cos, so we're dealing with ln cos x. plus a c, like that.
Excuse me, sir.
Hello?
On part D, what role is the derivative of u playing? Because it's like it's not even being used.
No, the derivative of u is used to switch things from x to u variable. After you switch, then you come and analyze it from here. Say if the forward from lean lands us to du over u, what will be the reverse from du over u? The reverse should land us at lean u.
Sir, I don't get on the linear. Can you explain again?
Okay. Since we are saying that if y is x squared plus x, differentiate y, you say dy dx is equal to 2x plus 1. Then somebody asks you to integrate 2x plus 1. They want you to get back to the question. So what you do is you have 2x to the power 2 over 2 plus x. So 2 over 2 will cancel and you get x squared plus x, which is y. So by integrating
Okay, sir,
what
thank
we
you. I
got,
understand.
good. For those who
Sir,
haven't,
D, my question is, since for the V, when we differentiate, when we integrate V, we are using tan in the expression, but U, we are just using U and not the derivative of U in multiplying. So I'm
we're just using
I'm saying there on X. Why didn't we use the derivative of U instead of just U?
Okay. We are saying that if the forward takes you to this, then the reverse must take you to the question. So if from lean u, when we differentiate, we get u prime over u, which is du over u. Then when we integrate, we must get lean u. There will be no du in lean. That's like there is no lean in the derivative. There will be no du in the integral. That's why du looks like it's not doing anything there. I'm just interested in u. Because of this direction, this is a downward fall, and now we have the upward. So here we're going to have x tan x minus ln of cos x plus c. Minus.
Yeah.
There's another minus here. So this minus and this minus will give us a plus. Hello?
Sir,
Hello.
so from the comma demonstration you are saying, so in short, integral questions will come as du over u. You take it back to the form of linear. Okay.
Yeah, it's like you need another example. Here's another example. So those what doing the screenshot, do the screenshot. Example is coming. You are very bad.
Okay.
Another example. The
Shit.
is to say that I'm just screenshotting it. Okay. This was D. Okay, we do E. The integral has disappeared. Where is my question? Okay. The integral of exact 5x plus 2 over 2x minus 1 multiplied by x plus 1 dx. You can't use by parts, you can't use power rule, you can't use substitution. So you break this into partial. Partial, you have a over 2x minus 1 plus b over x plus 1. And then the first step, you multiply throughout by the denominator 2x minus 1, x plus 1. So that you get 5x plus 2. When you multiply this guy by this one, this and that will cancel. Okay. And then when you multiply this by this one, the 2x minus 1, 2x minus 1 will cancel. So we have a x plus 1 plus, when you multiply this guy by this guy, the x plus 1 will cancel. So we have b 2x minus 1. So if you expand, you have 5x plus 2 is equal to ax plus a plus 2bx minus b. And then equate now like terms to like terms. So take 5x to be equal to ax plus 2bx and 2 to be equal to a minus b. So we have two equations. If we divide by x here, divide by x, divide by x, we'll get 5 to be equal to a plus 2b. From here, we can solve for a. A is 5 minus 2b. And then you go in the other equation, where you find a, you put 5 minus 2b. Then is the minus b there. So we have 2 minus 5 is equal to negative 3b. 2 minus 5 is negative 3. It is negative 3b. Divide by negative 3, divide by negative 3. So b is equal to 1. Then you come back where there's a, where there's b, take 1. So a is going to be 3. So now we have found the partial fraction of this guy. So what we will integrate is not this complicated thing, but now we integrate the partials. So we have 3 over 2x minus 1 plus 1 over x plus 1. Integration you can separate, so we'll do the separation. We have 3 2x minus 1 dx plus the integral of 1 over x plus 1 dx. Here comes the ln thing. If you have ln x plus 1 and we ask you to differentiate it, what do you get? You get dy dx is equal to the derivative of the inside, which is 1, over the whole inside. But this thing is what we have here. So that if we integrate it, we must get this one. Okay. For the other one, for the first piece, let u be equal to 2x minus 1. Then differentiate u, you get 2 dx. Then solve for dx, so you divide by 2, divide by 2. So dx is equal to du over 2. The other one, we're saying let u be x plus 1. Then du is going to be dx, 1 dx. Then you substitute now. So you have the integral 3 over u, since we have said 2x minus 1 is u, multiplied by dx, which is du over 2, plus the integral of 1 over u, dx is just du. So if we take 3 over 2 outside, since it's just a constant, so you can take it out, we'll remain with du over u plus du over u. Remember, these are different u's. So the first one will have 3 over 2 ln u plus ln u. Then substitute our ln, so I have 3 over 2 ln this u here is this one, 2x minus 1. So I'll put it in the absolute value because ln does not take negative numbers. Plus ln u, now this u is this one, x plus 1 plus c. If you can't remember what your u's are, then use different notation. You can use u and w the other side. This was an example that starts the partial fraction question. It ends up in ln as an integral. So that we log out and log back so that you can continue.
So another example like this.
When we come back, we have varieties of examples.